Today I am discussing about corrosion. Corrosion, corrosion means weathering or detrimental deterioration, detrimental effect or deterioration of the inanimate objects. What is corrosion? What is corrosion? How do you define? It is the detrimental effect or weathering effect onto some non-living beings. Okay, so getting damaged, materials are getting damaged, that is corrosion. That can be for metal, non-metal, everything. But mainly, we focus our attention, whenever we talk about corrosion, we talk about metal. Corrosion means metal. Normally, corrosion means we consider metal. When other things are also getting damaged, but that is not corrosion. Corrosion means normally we are considering metal. That means the damaging of the metal, like rust formation. It is a sort of corrosion. Okay, peel-offs, cracking, it is getting cracked, damaging materials. So these are all corrosion. See, it is written, corrosion is the deterioration or destruction of metals and alloys in the presence of an environment by chemical or electrochemical means. Let's understand one by one. Metals are getting corroded by chemical reactions. Number one. It can be corroded by electrochemical means. So let's focus our attention into this, chemical and electrochemical. First of all, chemical. Iron getting rusted, rust formation. So what is rust? It is called hydrated ferric oxide. Fe2O3.XH2. Fe2O3.XH2. That is called hydrated ferric oxide. That is rust. Now, why or how it is happening? Why or how it is happening? Due to reaction of water, moist condition, oxygen is reacting in the moist condition with this metal. That is called rusting. So chemical reaction, rust formation as example. And electrochemical reaction, suppose there is a raindrop falling onto some metal surface. Okay, a raindrop has fallen onto some metal plate. What happens? Metal contains iron, that metal, if I consider iron, so iron contains some impurity. Obviously there is some impurity. So if there is a copper impurity, now iron will act as anode and copper will act as cathode, and the raindrop will act as electrolyte. So electrolysis will take place and iron will act as anode, so it will be oxidized. Anode means oxidation. So iron will be oxidized, giving ferric oxide, and with water it forms Fe2O3.XH2, that is rust. So water has got importance. Without water, dry condition, this reaction cannot occur. Hey, attention this side, don't talk now, later. I am talking about some experiment. You have got certain test tubes. In all the test tube, you just put one iron nail. You have 4 different test tubes. In one you put iron nail and no water. You put some, the test tube should be quite dry, and you can add some anhydrous aluminum chloride for absorbing the moisture from the test tube. Then you put a iron nail and then stopper it with some cork. Another one, you put some water, boiled water. After boiling, the boiled water you put it, and one iron nail will be just put inside this boiled water, and on the top you add a few drops of oil and stopper it. Third one, you add just water and put some iron nail without any stopper. So that way, if you keep separate different test tubes, the first 2 test tubes will find no rusting, even after 1 or 2 months, you will find no rust is taking place. The iron nail was shining, still it is shining. There will be no rust formation. Why? Because in first one, you have totally removed all the moisture So it is totally dry. Dry condition, rust formation cannot occur. That's why it did not occur. Second test tube, you have totally removed all oxygen because boiled water you have used. You have put some oil on the surface so that oxygen from the test tube cannot penetrate in the water, and the nail was totally immersed in the water. That's why there could not be any oxidation without oxygen, and so rust formation could not occur. That means moisture is necessary, oxygen is necessary, otherwise rust formation cannot take place. So these are chemical reaction. So this rust formation is a chemical reaction. Now if there is a sulfuric acid from the raindrop falling onto some metal, there will be reaction. That is also chemical reaction. These are chemical reactions. But another idea I told you, if you have impurity and the metal, two different metals present. One is the metal concerned and other one is the impurity present in the metal. Or if you take alloy, more than one metal is already present. Not only always impurity. More than one metal making you alloy. So one can be more electropositive compared to the other. One is less electropositive. Metals are all electropositive. That's why I am not using the term electronegativity. Metals are all electropositive. So one is more electropositive compared to the other one. So two metals, and if there is a rainfall or any type of water in contact of that water, contaminated water will act as electrolyte. And two metals, one is cathode and another is anode. So oxidation will take place. Oxidation will take place. So that is electrochemical reaction. A small microscopic lake-length cell is formed. That is electrochemical reaction. So chemical as well as electrochemical, both the type of reaction happened. So this is the first point. Is it clear? Reacts that rust formation or any type of corrosion can occur by chemical and electrochemical means. Is it clear? Either chemical reaction will occur or electrochemical reaction will occur. Chemical reaction means direct reaction, like H2SO4 plus iron giving you FeSO4. So that type of reaction, or Fe2SO4 whole 3, ferrous or ferric type of compound will form. So this sort of reaction is chemical. There can be another type of corrosion, electrochemical, that occurs by some sort of water and two different metals present together in the form of alloy. So that is also sort of corrosion. So chemical and electrochemical means that. Second point, corrosion may be defined as the destruction of material by chemical, electrochemical or metallurgical interaction between the environment and the material. What is that? Suppose some machine is running, some pump. So it is rotating at a high speed. So there is a mechanical stress, shear force, sort of friction happening. So that is metallurgical different type of interaction. Okay, and this is getting heated up, the pump is getting heated up also, and then it is becoming cold. So this side of effect is not chemical or electrochemical, rather is mechanical. Expansion and contraction. Give one example. Rail line. Rail line in the night time become cold, and in the daytime when there is sunlight become hot. Daytime is quite hot, night time is quite cold. Then what happens? Hot and cold, hot and cold. Hot means expansion and cold will be giving you compression. So the same iron made rail line getting heated up, getting expanded, and then becoming chilled in the night, and it is compressed. So compression, expansion continuously happening, contraction and expansion. So what will happen? Stress will form, and that's why rail line cracks. That is also sort of corrosion. Not only always reaction, there can be mechanical force also. Achha, on the flyover, so many cars are going, rolling friction, continuously tire is screeching on that, rolling friction, right? So that is also getting corroded day by day because of that friction also. Getting erosion occurring on the surface. Ghiz jata hai na, ghiz jata. That is erosion. So getting eroded on the surface, that is also sort of corrosion. So but metal and alloy, mainly the corrosion means what do we mean? Metal and alloy deterioration and destruction with time. But other things also may be damaged. Like you have a monument, statues, buildings, they are also getting damaged with weathering effect and all. But we are normally we are using the detrimental effect on the environment. So that marble statue may become dull after some time. But we don't use the term corrosion there. We say that it is getting eroded, it is got peel-offs, okay, got grooves and holes, pit on the surface. But corrosion terms particularly we are using for metal and alloys, pure metal or alloy. Okay, different type of such things you can find that corrosion. Basic cause of corrosion, instability of the metal in their refined forms. Instability of the metals in the refined forms means what? If you take some metal in the pure state, it is prone to be oxidized. Aluminium in presence of air forms aluminium oxide, and that's why it becomes dull. Freshly made aluminium sheet, it is very lustrous, looking like platinum, so good, or silver. Okay, but after some time it becomes dull. Why? Because on the surface some aluminium oxide will be formed, which will make the metal less shining or less lustrous. Okay, that happens for aluminium. And for iron, rust. What else? If you take some copper material, after sometimes it becomes, if you use copper for a few days or few years, what happens to the utensil? What happens? Spots on the surface. Okay, what green coloration is there? Copper, green color. Why does it becomes green? Basic copper carbonate. Basic copper carbonate. What is the compound? COH whole 2 dot CuCO3. Basic. Why? Because copper hydroxide is there. That is basic, and copper carbonate is also there. So combine COH whole 2 dot CuCO3 XH2. That is called basic copper carbonate. Rust formation is also some sort of hydrated ferric salt. So this is the thing. Okay. The basic cause of corrosion, instability of metal in the refined forms, means in the pure form. Refined forms means in the pure form. The metal tend to revert to their natural states through the process of corrosion. See, how we made the iron? Can you tell me? How iron is manufactured from the ores? What is the ore used for making the iron? Key ore use kora hai iron extraction jonno. What will be the ore? What type of ore is used? No idea? Iron? Iron का ore क्या है? Hematite and magnetite. Usually hematite. So hematite is Fe2O3. Fe2O3. So how do you make it? Iron by carbon reduction. Don't you know this carbon reduction process making manufacturing of iron? If no, you have to learn, because that is there in the chapter afterwards. Okay, industrial chemistry we have involved. Lot of these things are there. So you will be learning. So for the time being, you should know Fe2O3 plus carbon giving you iron plus carbon dioxide. That is the way the reaction is happening. So we are getting iron manufactured by carbon reduction of iron oxide. So metal tends to revert to their natural state through the process of corrosion. Natural state means what? Oxide was the natural state. So iron, what will do? Unnaturally you made it. Now it will try to go back to the nature itself. Okay. We made it by some process. Now if we leave it to the nature, slowly it will revert back to the original state. State of occurrence. State of occurrence समझते हो? Do you understand? No. जहाँ में जैसे हिसाब में मिलता है, how we get it, जैसा मिलता है उसका नाम है state of occurrence. तो आयरन का state of occurrence क्या है? Fe2O3. That is called hematite. Hematite, okay? Fe2O3 is called hematite. So we get iron in the form of oxide from the nature. How do we get calcium from nature? Limestone, calcium carbonate. So whenever we just keep it in the nature, so the metals usually try to go back to their natural state, because that is their most stable state. So that's why they will revert back to the natural state to the process of corrosion. That is the meaning of the last line. So this is corrosion. In front of you, the metal, particularly the GI pipe, you know GI pipe, galvanized iron pipe, or the water pipe used in the bathroom. Earlier days people used to use. Nowadays all are using PVC plastics. But earlier this GI pipe was enormously used. Now why people are not using GI anymore? Because it gets corroded, number one, and once it is corroded, it is very difficult to open, change. If suppose a part of you want to change, so if this is the situation, how do you change it? You have to break the whole thing. The whole thing you have to throw away. You cannot change it. Replacing is not possible. See the situation. This also, pump. If this type of things are there, this is pipeline. That very difficult to change the metallic things. That rainwater pipe. Have you seen iron-made rainwater pipes? Earlier people used to use. Still in the toilet outlet, people are there. You will find in the old building, lot of those iron pipes are coming from the sanitary tank, sanitary pipelines. Sanitary pipelines are still iron made, cast iron made. Okay, corroded, and there will be rust formation. So that type of pipe still you can find in old buildings. Iron made toilet pipes, outlet pipes, gas pipe, gas pipe, that one, iron made. But the problem is mainly once it is damaged, difficult to change. Someday you have to change, so when you want to change, you cannot replace a part, throw the whole thing out. That's the problem. Now corrosion can be classified in different ways: chemical and electrochemical, that I already discussed in detail. High temperature, low temperature, that also I told you. Rail line, daytime high temperature and nighttime low temperature. Okay, wet corrosion and dry corrosion. In presence of moisture, the corrosion occurs like rust formation. That is called wet corrosion. Sometimes dry corrosion also can occur. Acid deposition can take place where moisture is not needed. Acid getting deposited on the surface in the form of droplets, globules. That is called dry corrosion. So then also the metal gets corroded. You will get lot of small spots on the surface. That is also giving corrosion. It is called dry corrosion because we have not. It is not depending on any moisture. Because liquid droplet, acid droplet, if there, already it contains some water, so reaction will take place. So that is called dry corrosion. Dry in the sense no separately moisture required. It in the presence of gas, vapor, mainly at high temperature, also it can get corroded. Okay. Electrochemical in front of you, zinc plus HCl, ZnCl2, and anodic reaction. The zinc is getting dissolved, and there can be some hydrogen liberation because of H plus getting deposited at the cathode. So hydrogen gas can be liberated at the atmosphere. Okay. If any solid getting solid or liquid getting accumulated on the surface, we call it deposition, and if the gas is generated, we call liberation, because gas goes up. That's why it is liberated. Okay. So gas is liberated, solid precipitated or accumulated. Liquid droplet usually accumulated on the surface. The terms are different. From that you need to understand. Okay. So here the zinc plus HCl. Where from HCl? From environment. Liquid HCl droplets are floating in the air. So that can come on the surface of the zinc, reacting, producing Zn chloride and zinc chloride and hydrogen. And the hydrogen is getting liberated in the atmosphere. Now electrochemical principles. See here. This is anode and this is cathode. So hydrogen is getting deposited at the cathode. Two different metal may be present. So and here iron is there. So iron is getting dissolved in the liquid, forming Fe2 plus. And here H plus is getting deposited and produced hydrogen gas and then getting liberated. It is getting discharged over here. So what is the reaction? Electrochemical process. These are called microscopic Lakeland cell. Corrosion occurs in the microenvironment. Very small scale electrochemical cells are formed. hundreds of these electrochemical cells are formed on the surface, and then the corrosion occurs. Now, factors influencing corrosion. So many factors are there. Achha, you have two different metals. Their potential difference. If you have two different metals, their potential difference can be one cause. If the potential difference is very low, corrosion will be less effective. There will be not much corrosion. But if the difference in that electrochemical position is there, like iron and zinc and copper, for example, then zinc will be very fast corroded, because the gap between the zinc and copper is quite high. And what is the potential difference? 1.1 volt, E naught. E naught will be 1.1 volt. So much of potential difference. That's why the zinc is getting oxidized so easily. These are types of corrosion: pitting corrosion, cavitation corrosion, galvanic corrosion, fretting corrosion, crevice corrosion, intergranular, transgranular corrosion, and stress corrosion. Let's understand one by one. First, pitting corrosion. What is pitting corrosion? Pits and holes are formed. There is on the surface there is a small hole. You cannot see, maybe the microscopic hole. Okay. But inside, the hole has become quite large, which is not seen from the top. ऊपर से देख रहे हैं एकदम ठीक ठाक है, but अंदर से खोखला बन चुका है. That is called pitting corrosion. पीट बन चुका है, होल बन चुका है, खड्डा बन चुका है, लेकिन अंदर है, बाहर से ज़्यादा दिखता नहीं है. हाँ, there can be some mouth. You can see there is a hole, but how much deep it is inside, that always may not be visible. ऊपर से हमेशा दिखेगा नहीं कि अंदर कितना ज़्यादा corrosion हो चुका है. That is pitting corrosion. This example. There can be narrow, deep, shallow, wide. Different types of corrosions are there. But mouths are usually maybe small also, but inside the corrosion can be quite widely spread. Corrosion can be widely spread inside. How do you understand all these things? Surface phenomena by ACM, scanning electron micrography. From the scanning electron micrography, surface characteristic technique, measurement technique, you can find out how much what is the situation of the surface. Next is cavitation corrosion. Cavity, what is the meaning of cavity? Cavity, yeah. You understand cavity? Cavity into the tooth, dental cavity. Cavity কতটা শুনেছো তো? কি করে ফিল আপ করে? ডাক্তাররা ফিল আপ করে দেয় না? কি দিয়ে ফিল আপ করে? Dental filling, তাই তো? আচ্ছা. That is also a sort of cement. Okay. So that is so cavity means hole. So cavitation corrosion is also hole, but that pitting corrosion and cavitation corrosion, what is the difference? See here, it is a globule from the beginning. While making, there is a manufacturing defect. There is a hole here, bubble here in the liquid state. Now, when it is frozen, solidified, this bubble will spread into small bubbles. It will spread into small bubbles inside, not seen from above, not seen from the top. So what happens? This portion becomes weakened. This portion will become weaker, and it may break, crack. And where do we use our metal bar for construction? TMT bar. Do you understand what is that hardening, annealing, and tempering of steel? Normally, we just tell that this is made of iron, that is made of iron, but actually wrong. This is all made of steel, not iron. And steel is alloy, iron is metal. They are not same. But sometimes, just in a colloquial, normally we just casually say, this is iron made, lohe ka hai. But actually, none of them are made of iron, because iron in the pure state is very much unstable and it will be degraded very fast. So normally people are not using any iron made material. All are steel almirah. But still these bars are also steel. You don't find iron. All are steel. Some examples of iron I can tell you. actually iron is there, that is cast iron. That is real iron. Cast iron, for example, the bathroom, just a few minutes back I told that toilet pipes, gas pipe from the toilet, that is iron made, is actually cast iron. This is one. Another one, manhole top, manual lead, manual ka lead hai na, that used to use cast iron earlier days, but nowadays it is not. Nowadays people are using concrete, cement. मैनुअल का ढक्कन अभी सीमेंट से बनता है, लेकिन पहले वो आयरन से बनता था, कास्ट आयरन. इट वाज मेड ऑफ कास्ट आयरन. नाउअडेज पीपल आर मेकिंग दैट सीमेंट, as you can see here and there. Okay, so cavitation corrosion is sort of holes or bubbles inside the metal. So if steel is an alloy, what are the metals present in that steel? There can be nickel steel, chrome steel, and there is one inorganic material, carbon. Some percentage of carbon will be there. Why? It is non-metal, why should we use it? It gives some strength. Because it is giving some iron carbide. Announcement করব আমি একটা রেকর্ডিং করছি ঠিক আছে একটু পরে তাহলে আপনার হয়ে গেল রেকর্ডিং ওকে তাহলে স্যার এখানে স্যার এটা কি সিএসসি হ্যাঁ 5-7 মিনিট ঠিক আছে Okay, so these are the holes. Galvanic corrosion. Next is galvanic corrosion. This is zinc. It is acting as anode, and copper acting as cathode. Now what is happening here? Zinc is getting dissolved, slowly it is forming Zn2 plus. So that is the corrosion state. Zinc will become Zn2 plus. And here copper is inert comparatively, it will not do anything, and what will happen, hydrogen ion from the acid droplet will be discharged here producing hydrogen gas. If copper is present, it will not be corroded, but iron will be corroded. Copper and iron if present together, then what will happen, iron will be corroded because iron acting as an anode. Okay, but zinc and iron if present together, then zinc will be corroded, not the iron. That is the difference. From the picture you can understand, the iron is intact here, but the zinc is getting corroded. On the other hand, this one, iron is getting corroded, but copper is intact. Depends which one is cathode and which one is anode, because we know anode gets dissolved, anode gets oxidized. So here zinc is getting oxidized, not iron, but here iron is getting oxidized, not the copper, because of the electrochemical position. In the electrochemical series, their position is different. Zinc is above iron, that's why iron gets corroded here. But copper is below iron, that's why iron is getting corroded, not the copper. This type of reaction is called galvanic corrosion. Because there it is what is happening? Electrochemical reaction is happening. Cathode, anode and some acid as electrolyte. Amount of corrosion such as temperature and surface finish of the metal. Okay, you read out afterwards. Okay, I don't need to discuss all this. Fretting corrosion. Next is fretting corrosion. See the picture. This from the picture you will understand what is fretting corrosion. Some sort of that in the machine parts getting corroded, not because of chemical or electrochemical way, but mechanical way. When slide motion is there, welded particle tear away from the opposite surface and react chemically with the atmosphere, forming debris and powder in the joint. Suppose there is some sort of soldering. So solder material comes out because of vibration friction, and that is forming powdered material on the surface. That is a type of corrosion. That is called fretting corrosion. So pitting corrosion, crevice corrosion, fretting corrosion, crevice corrosion. See the picture, we understand better. See, this is called crevice corrosion. Very simply I can make you understand. This nut is intact but corroded inside. The brown color you can see, that portion is corroded inside. Okay, that is corroded inside. intergranular and transgranular corrosion. The metal contains some small crystalline zone. Metal contains small crystalline zones. In between these crystalline zones, there will be amorphous zone. The crystalline zones are comparatively tougher. Amorphous zones are vulnerable, and that is getting corroded. So, in between the crystalline zones, there can be some weak points, and those weak points will be corroded. That is called intergranular, transgranular corrosion. Stress corrosion. All the types I am discussing. Stress corrosion. Already I told you. When lot of cars, trucks, vans going from over the flyover, there is a lot of stress involved. It is getting loaded and then unloaded. Load is getting compressing this bridge and the load is removed. So that way a lot of stress is involved. That is giving sort of corrosion. And it may break or crack. Like this. Crack happens inside. That is called stress corrosion. Because of stress is happening. Acha, by the way, if you try to fold it, but not folding totally. If you fold it will break, it is a pain. If I fold it will break. If I halfway fold it and leave, and that way if it is done continuous over a long time, sometime it will break. Acha, sometimes you are using this principle. You don't have a scissor with you or you have a wire, you want to cut it. So you fold it again and again and again. You do it, and cut it. So practical example, that is stress corrosion. You are giving stress more and more so that it breaks.
Statue of Liberty made from copper was originally brown in color when brought to USA in 1886. But today it looks bluish green. How did its color change? It happened due to a phenomenon called corrosion. When a surface of metal is attacked by air, moisture or a chemical substance, the metal is said to be corroded. This phenomenon is known as corrosion or weeping of metal. Metals like aluminium, copper, silver, and iron corrode easily. Aluminium articles lose their shine and become dull soon. This is due to the corrosion of aluminium metal when exposed to moist air. Aluminium reacts with oxygen present in the air to form a thin and dull layer of aluminium oxide on its surface. Due to the formation of this dull layer, the aluminium particles lose their shine. Green color deposits are seen on the copper roofs or copper metal tubes when exposed to carbon dioxide and water present in the air. This is called patination of copper. These deposits are of basic copper carbonate, which is formed by the reaction of copper with carbon dioxide and water present in the air. Lead also corrodes. A white deposit of basic lead carbonate is formed on the surface of lead when it comes in contact with moist air. Notice that the articles in jewelry made of silver turn black when kept in open for some time. Silver metal tarnishes in presence of hydrogen sulfide gas present in the air, and a black coating of silver sulfide can be seen on its surface. On the contrary, the gold and platinum articles retain their shine even after several years because they are resistant to corrosion. They are highly unreactive metals and remain unaffected by oxygen, water vapor, and other gases present in the atmosphere. Due to their unreactive nature, gold and platinum are used for making jewelry. Sometimes a layer of additional material is seen on the surface of iron articles. This is known as rust, and the process of its formation is called rusting. Rusting can be defined as the slow oxidation of iron by the atmospheric oxygen in the presence of water or moisture. It is the most common form of corrosion. Remember, while the other metals are said to corrode, iron is said to rust. Iron, when exposed to moist air, reacts with oxygen and water to form hydrated iron oxide. The hydrated iron oxide is called rust, and it is reddish brown in color. Some factors increase the rate of rusting. Presence of gases like carbon dioxide, oxides of sulfur, and nitrogen in the air increases the rate of corrosion. The rate of corrosion of metals can be decreased by keeping metals isolated so as to avoid direct contact with air. The necessary conditions for rusting of iron are the presence of air and water or moisture. How can we prove